Perfect. So thank you for giving us an opportunity to talk about our technology. We're a relatively new startup company out of Silicon Valley, and what we're really focusing on are problems within RAID data protection and how the speed of drives that are coming out is really overwhelming the ability of the older technologies to take care of that. So we are known as Graid Technology Inc. Graid as in Grade from a pronunciation, it's not G-RAID. So let me go ahead and get started. And we're going to talk about RAID bottlenecks and what that is and why it's a bottleneck. And then our solution and a few other things. So there are some slides that I probably won't spend much time on. Others I may spend more time on. Definitely stop me if you have a question, or you can wait till the end and we'll have a Q&A session as well. So let's start talking about RAID bottlenecks in general. And the market is changing. We've gone from spinning hard drives to SSDs that were connected via SAS or SATA, and now we're moving to NVMe, direct attach NVMe flash, which is very, very fast. And the problem is flash storage is evolving to the point where traditional software-based RAID and hardware-based RAID technologies running on ASIC chips just can't keep up with the performance. And what we're going to do is talk about why that is and what our solution to this problem is. From a hardware RAID perspective, when you look at a traditional hardware RAID card, it's a PCIe device. It's probably got batteries on it and some caching and things like that. And it plugs right into the current iteration would be a PCIe Gen 4x16 card. And when you have by 16, that means you're utilizing 16 lanes. And on PCIe Gen 4, that's a maximum throughput of 32 gigabytes a second. The problem is SSDs, NVMe SSDs specifically, PCIe Gen 4, they're by 4 drives, and they can go 7 gigs a second apiece. So essentially, when you connect 4 of these to this card, you have already saturated that card's ability to pump data. So even though 32 is the maximum, the testing of most of these cards, they never get beyond about 28. That's just because of the ASIC overhead on board and all of the work and house cleaning that has to happen with PCIe and RAID and parity calculations. So really, once you go beyond 4 drives, you're not gaining anything in terms of performance. So why buy all these really expensive high performance drives and plug them into something that's clearly a bottleneck? So what some customers will do is say, well, hey, I'm building a server that's got 8 drives or 16 drives. We're now seeing servers with 24 NVMe drives. And the way that they'll try to manage RAID on those is use software-based RAID. So you'll look at things like Linux MD80M RAID, storage spaces on Windows. And essentially, the problem there is the infrastructure software code that does RAID and parity calculations is now running on your operating system alongside your applications. And so now your apps are competing with this software for CPU cycles. And as you increase the number and speed of the NVMe drives, you have more and more CPU cycles that are required to keep up. Software RAID, when you're running RAID 5 or 6, can consume 30 to 40, sometimes 50% of a CPU. And during a drive rebuild, that can climb as high as 75%. Essentially, that server is very, very degraded when it's going through a drive rebuild. Now, most customers try to overcome this by ignoring RAID 5 and 6, and they'll just go with RAID 10. The problem with that is you essentially have consumed half of the usable capacity of the drives for RAID protection. And so that becomes an expensive problem. And it's still, even with RAID 10, the speed of these drives cause so many CPU interrupts that it still consumes a very, very high percentage of the CPU. So it's 2 problems. Throughput of the drives not being able to get to the applications with hardware RAID, and it's the scalability problem with software RAID consuming your CPU. And that's what we set out to solve. And so we've got some smart guys who really figured out that there are 2 problems. CPUs really aren't good at math, and RAID calculations are using Reed-Solomon algorithms, and they're very math intensive. And the other problem is PCIe Gen 4x16 is a bottleneck when it comes to more than 4 drives, of course. So we came up with a pretty novel approach, and that is, let's write a software RAID stack that we can put on a GPU. And we use that GPU because the CUDA cores on these GPUs are far faster at doing mathematical calculations than your CPU is. And it offloads it from your CPU, minimizing the software RAID impact. At the same time, we are utilizing out-of-path RAID protection. And so some of our patented technology is around how we communicate with drives across PCIe using peer-to-peer DMA. And that's a whole different ballgame than having the drives physically connect to our card. These GPUs are standard NVIDIA GPUs. They do not have drive connectors on them. There's no place to plug the drives. And so we're going to go through how this is implemented in a typical server, and then some of the use cases, and show you some of the performance numbers that we're able to achieve. Before I do that, we have a quick poll question.
Alexa?
I can't see
Sorry,
if the poll came up.
Sorry, we're having issues with the poll here.
There it is.
Give you about 30 seconds to answer the poll, and then we'll share those results. Right. So these are the results we're seeing, Kelly.
Great. Thank you for those answers. All right, so to continue on, let's talk about how we implement our technology. In this kind of an example, these are drives that are plugged directly into PCIe. So you would typically see drives with a U.2 interface, M.2 interface. We're starting to see E1 and E3 type interfaces that allow even higher density and numbers of drives. But essentially, since they're all plugged into PCIe, when we drop this GPU into a by 16 slot, all we have to do is load our driver on this, and that is our software. And once that driver is loaded, your operating system will now see that GPU as a RAID controller. It will no longer see it as a graphics card. And once we are loaded on this card, we can now see all of the directly attached drives. And we can then carve this up however you wish. So we can support up to 32 drives on a single server today. We will be increasing that in our next release. You can divide that up into 4 separate drive groups or RAID groups. Each of those RAID sets can have a different level of RAID. So you could do a RAID 0 strike, you could do RAID 10, RAID 1, RAID 5, RAID 6, etc. And then from within those RAID groups, we can carve out as many as 1,024 vDisks. And that virtual disk is what we are now presenting to your application and to your operating system that look like physical disks. And that's what your applications talk to. This peer-to-peer technology I was talking about allows us to have an application actually write the data straight to the disk and also read. So if we get a read request, for example, we don't go to the drive, read the data, pull it into our card, and then turn around and send it up, to the operating system. We actually get a read command, and then we redirect that to the drive and instruct that drive to directly send the data back to the application. That's how we're able to get the full throughput of all these drives, because they're not going through a single slot bottleneck on the motherboard. That is our peer-to-peer DMA. The other side of this is, as writes are occurring, of course, we create parity calculations depending on what RAID level you're using. And we're doing that on the CUDA cores of this GPU, which is far, far faster than running that up on the CPU. And it frees that CPU up for your applications. And so you can get a lot more done on a server now with this type of a system. We've even had customers realize they could buy a lesser CPU and save money because the CPU was now freed up to work on applications. We also have HA kind of capabilities, so we can drop another card in. And in that kind of a scenario, you would have half the drives on one card and half on the other, and then they can actively and passively protect each other. So if either one failed, the remaining card can still take over the RAID groups that this card was managing, and you can stay up and running. Automatically failover, but you will stay running until you can schedule the time to replace that card. So, and we have another question.
Oh. So again, about 30 seconds. All right.
Great.
So here are again those results.
Excellent.
I think that's interesting.
Yep. Very cool. So we're going to talk about some of the performance numbers now and how we help future-proof your environment. We've been talking about PCIe Gen 4. Well, Gen 5 is coming out, and we're doing a lot of testing with Gen 5. And we can start talking about, once again, this hardware bottleneck that we mentioned before. The leading hardware RAID provider, claims that they can handle up to 32 drives. But if you had 32 drives on here, you're still only going to get 28 gigabytes a second throughput. So it doesn't make any sense to connect that many drives to these cards. And it gets worse when you look at Gen 5. Whereas with us, if you have 8 cards here with 56 gigabytes of potential throughput, we deliver that because the data is not flowing through our card. We're not causing a choke point or a bottleneck. So we give you a much higher percentage of the usable read and write performance of these drives, and as well as the IOPS. And as that scales and you add more drives, you will see linear performance improvements. So we've just doubled the number of drives, so we've doubled the throughput. If you double the number of drives on the previous card, you're still stuck at 28, which is the whole problem. Gen 5 makes it even worse because Gen 5 drives themselves are now 14 gigabytes a second. And so it would only take 2 Gen 5 SSDs plugged into a traditional hardware RAID card to max out the potential performance. And what's interesting is our card, we have a Gen 3 and a Gen 4 card, but because we don't run the data through our card, it doesn't really matter how many lanes we have. It's really not an issue. There are differences in the two cards that we can talk about, but in general, we get out of the way of the data. So once again, even with our Gen 3 card, we're able to get 112 and even now up to 220 gigabytes a second. So we have a Gen 5 white paper where we tested 16 Gen 5 drives and we were able to achieve 224 gigabytes a second on write. And then when we start talking about, I'll skip that, but when we start talking about the real numbers here, and this is Gen 5 testing, with 24 drives, we were able to achieve 260 gigabytes a second in throughput and 28 million IOPS. And this matters because to achieve these numbers with the other technologies, you would have to buy a number of additional servers in order to achieve this kind of performance. So we can give you much more performance in a much smaller footprint. The other thing to notice here is the rebuild performance. I talked about how software RAID will kill your CPU on rebuild. Traditional hardware RAID cards will just take a long time to get it done. So, we're talking about 15 terabyte drives can be rebuilt in hours versus days. And so during that period of time, you have a degraded state that you're running in, number one, and number two, your server is vulnerable to another failure for a longer period of time when it takes a long time to do a rebuild. This is our Gen 5, our Gen 4 card. And then we also have a Gen 3 card. And the numbers here are still extremely respectable, as you can see, outperforming either one of these. So Just depends on what your needs are as to which card might be the right fit. So we talked about lanes. These traditional hardware cards, are only limited to 16 lanes. With us, the SSDs connect directly to the PCIe bus, and we stay out of the data path because of our peer-to-peer DMA technology. The other thing I think to just wrap up this section is that we're flexible and future ready. All of the customers that have our technology today are receiving a software update that almost doubles the performance of our card, and that's because of some of our new intelligent parity reduction technology. So we will be able to continue to add new OS support. It's possible that we can add compression and encryption. There's a lot of other features and functionality that is in our software. You don't have to wait for a new card to come out that's got a new ASIC on it someday to take advantage of features that we're adding. It's very easy to install, plug and play out of the box. We support tons of operating systems now. It's very scalable, and the performance that we're getting is world record. And once again, liberates your CPU. So I think we have some questions again here before we move on to some of our use cases. Yep, another question.
All right, about 30 seconds. All right.
Oh, there's the. Great, thank you for that. So one of the things that we can do is we can do better performance than software RAID 10 and give you RAID 5 or 6, which means you can get 50 to 80% more usable capacity with better performance offloading your CPU. So that's one of the reasons we asked that question, is because that's where we can make a difference when it comes to software RAID. I'm going to go through some of the different places where we're experiencing success with this technology. AI and machine learning jobs. And it takes a long time to do a job like this. Another one would be using GPUs to do gene sequencing. If we can cut this from 12 hours down to 2, that's a massive improvement in results for these customers. Getting involved in 4K video and surveillance. So a couple of different areas around this. Things like, how do you capture real-time motion video, store it quickly from 50 cars on a racetrack all at the same time? You have to have fairly large infrastructure to do that. We're actually doing quite a few things with military customers where they're capturing information in mobile platforms like aircraft, and we can actually give them much better performance on a single server than what they have to do with a large cluster today. Well, that costs a lot of money to carry that kind of weight around on an airplane. So doing much more with much less hardware is one of the reasons that we fit well in that kind of a space. Automotive, aviation, and drone, we're working with several companies that are including us on self-driving car fleets and self-driving truck fleets. And we even have a customer who builds inspection portals. So when a train goes down the tracks and it goes through this inspection portal, they're able to use a number of 8K high-def cameras, and they can capture that train as it's going through at full speed. And then they use trained machine learning models to actually analyze that train and see if there are any safety problems, like brakes that are worn out, or if there's a hole in the train, or all kinds of different things that it can look at and then alert someone that they need to pull that train over at some point and do some maintenance work on it. So trying to reduce, all kinds of accidents within that space. High performance computing, we have partnered very heavily with companies like BGFS and Luster to provide very, very high speed RAID drive level protection underneath a storage node that's used in a scale out parallel file system like this for these kinds of environments. When you think about HPC at a university, for example, or in a research lab, if they're running an experiment, sometimes even with the kind of performance we're talking about with hundreds of compute nodes, the actual job can take weeks and weeks and weeks. And it costs a lot of money if you have a glitch that causes drive failures, for example, that would cause you to have to start all over again. And so once again, we can provide the performance that they need with drive protection. In some cases, these HPC environments will use RAID 0 for scratch because they need that performance, but essentially they're running without a parachute. And so we can give them the same performance with data protection, and that's kind of the cool thing that we're doing there. Emergency healthcare, one of my customers is a medical company that makes MRI systems and makes PET scan and CAT scan machines, and they want to they're embedding our technology into the servers that sit behind these machines. And if any of you have ever gone in for an MRI, you know it takes a while, and a big chunk of the time that it's taking is writing data down to disk and making sure it's protected. And if you can increase the speed that happens, that means you can help more patients with that machine because you can accomplish more, more of those kinds of scans in a day. And that also helps the companies that pay a lot of money to buy one of these machines pay for it faster. So you help more people and you can pay for it faster because you can accomplish more per day with that machine. Local databases. So when we look at things like high frequency trading and they're using in-memory compute databases like Redis and MySQL, we accelerate those around the IOPS arena because IOs per second are much more important. Also, read latency with us is so low that you get very, very high speed access to data, which gives a lot of the financial companies we're working with, essentially a competitive advantage. SAN and NAS, I've worked in the storage arena for a long time. I've worked for companies, that made arrays and things like that. And those kinds of products are still extremely important in the market. We can augment them. So, we're seeing customers who are deploying large virtual desktop environments, and the problem they have are boot storms where people are logging in at the same time to their desktop and it's trying to pull the same operating system image. And, they can put that on our system and we can provide that very fast and alleviate that boot storm problem. And then once they're up and running, they can use their traditional storage arrays for their data protection. We have customers that are doing some interesting things with microscopy. So there's a fairly well-known research hospital in Memphis that some people probably have heard of that help children out, and they've developed a atomic microscope that generates a huge amount of data, and they need to be able to write that really, really fast and have it be protected. If they can't get something like 100 gigabytes a second on write, which we can do, then it takes much, much longer. And so once again, they're trying to help more people, and helping more people by making the system faster is what we can do. And then lastly, things like going back into an environment where we've seen customers who have found that many of the older servers that are failing, it's coming down from old RAID controllers that have batteries that have burned out or they're failing. And if you have a stack of machines like this, especially when you think about the supply chain problems that we've seen ever since COVID hit, and if you can take some of your existing servers and retrofit them with NVMe drives and something like our technology and rip out the old controllers, if you can get a lot more performance out of those machines, then you can reduce e-waste, quit throwing things away. Instead of having to constantly buy a new machine, you might be able to increase the lifespan of existing technology for another year or two or three. And so those are some of the other areas that we've been having success in. So I think one more question here.
All right, so this one might take a little bit longer. Lots of options here.
Sure.
I'm not sure we have a lot of auto, aviation, and drone customers on here.
We have a couple. So I think this is kind of interesting to see.
We do.
Yeah.
There are some drone people.
Yeah. And I think it's good for everyone to see how their peers are answering.
So I'm going to just tell you a little bit more about our company, and then we'll stop for some Q&A. We have been winning lots of awards. I mentioned we're headquartered in Santa Clara. We were actually at Flash Memory Summit last week, which is kind of a industry show where there's all the flash companies and NVMe companies and storage companies, and we got a best of show award, which was kind of nice. And we've gotten quite a few other awards within this space. And Leander's our CEO. Tom, my boss, is on the call today, so hopefully he's happy with my performance today. But we have also quite a bit of a development that happens over in Taipei. And in fact, we were very excited that a bunch of our folks from Taiwan came over and were at the event with us last week, and they had attended the event and helped us at the show as well. We are very partner centric with OEM partners like Supermicro and Gigabyte and such, as well as the drive manufacturers that we partner with, and also our resellers. And Arkay, of course, is one of our resellers, and we have others around the world that we've been working with in various vertical markets. So I think to wrap up, our industry leadership, our disruptive innovation, our strategic partnerships with OEMs, our global capability, and the performance that we offer is what sets us apart. There really isn't another RAID technology on the market that does what we do. It's very unique. And the comment I get from a lot of people when we first talk about it is, why didn't someone think about this, think about doing this sooner? And the only thing I can say is good thing they didn't, because we were the ones that came up with this idea. And it's very, very exciting to be part of this market. And there's a lot of really cool things happening right now. So I think we're going to do some Q&A. Let me see what the next slide is. That's, yep, Q&A time, Alexa.
Sure. So if anyone wants to unmute and throw any questions in the chat, we can get those answered for you.
I have a quick question, Kelly. Are there specific corporate applications like VDI, specific databases? Are those the largest growth area you are seeing, or is it more machine learning, AI? Is there a highlight of where you're seeing the most penetration in this market, or the most need for this technology?
I think just because of the nature of research institutes and national labs, we've got presence at places like Sandia, Department of Energy, Idaho National Lab. They tend to be early adopters. And so that was where we started having some of our first success, but definitely getting involved in the banking industry and financial industry with high frequency trading and high performance database is a newer market. And a lot of people run their database in the cloud, but a lot of companies still run them on-prem or in a colo with their own hardware because of security reasons, and they want the best speed they can possibly have. So we see that as probably a faster growing area for us.
I have a question that popped up here in the chat. Do you support NVMe OF? So over Fabric, I believe is the
Yes,
question.
we do. That's actually a good question. Some of our backup slides actually go into that. So we'll talk real quick. This is a few more slides, and then we'll go back to the Q&A, because it's a little harder to answer without talking about it. And it's not just a yes or no answer. So for those that don't know, NVMe over Fabric is a relatively new technology where we can take a drive and make it appear across a network in another server. But when you do that, it actually looks like it's a local disk in the other server. And so there's a lot of really cool use cases for that. And one of the reasons to do it is it's very, very fast. You've eliminated iSCSI and TCP/IP based, connectivity issues to give much faster access to that flash. And so, what you'll see with NVMe over Fabric, it's an open standard that supports existing protocols like Fiber Channel. Probably the most popular one out there right now is Rocky, which is RDMA over Converged Ethernet, which was kind of pioneered by Mellanox, and which is part of NVIDIA now. But we also support this over InfiniBand, and we're starting to see some manufacturers build these solutions with TCP. I mentioned low latency, high performance, and scalability. And so the question is, where does our technology, which once again we call SupremeRAID, what does it fit in? We actually can provide data protection because NVMe over Fabric is basically a drive sharing technology across a network. It doesn't have any kind of provisions for protecting the data that you put on drives. And so we still need some sort of data protection, whether it's a simple mirror or some sort of RAID to be able to do that. And we actually outperform all the traditional software because we offload it to a GPU, as we've told you and shown you. And you can't even really do this with the traditional hardware cards. And the other thing is our support actually can be on the target or the initiator side. And I'll explain what that is. As we went through before, our GPU and software-based solution with SupremeRAID takes SSDs, NVMe SSDs, groups them into a RAID set, and then we create these virtual disks that are presented to your application with very, very high speed. When we start talking about NVMe over Fabric, when we act as a target, what we can actually do from our card is use the target offload function. I can take a virtual disk that we've created from these physical drives and share it to another server across this network. And this would be using Rocky, for example. And so this server now thinks it has a local disk. And when it writes to it, it's actually coming across the network. And then we're handling all that data protection across the physical disks behind that. So that's the target side. On the initiator side, we actually work with a number of companies that build what we call a JBOF enclosure, just a bunch of flash. Western Digital is probably the most prominent one that we work with. They have a product called OpenFlex Data 24. And it's essentially a chassis, a 2U chassis that has 24 NVMe drives in it. And then it has up to 6 100 gig connections. And you can either plug those into a network switch and put it across a switching fabric, or you can actually have servers directly attached. And with their software, you can use their software to do target offload of these drives into another server. And then we drop our card into that server and take those drives and create RAID sets across those drives. And then inside that server, we present the virtual disk to the applications. And so the flexibility comes in because you can have many machines connected directly to these chassis or across a network. And then there are quite a few use cases for NVMe over Fabric that we see. So example, being able to handle things like a failed host migration. If you have a server that failed, you could have a standby server come up and our card can mount those drives across the network and immediately start processing again, because we store all of the RAID configuration information on the drives. There's nothing stored within our card. things like high performance file systems. We mentioned scale out file systems like BGFS and Lustre and Ceph, where we can create storage servers that are using NVMe over Fabric on the back end. And then so you can have a stack of 1U machines connecting to these JBOF enclosures, and then the file system runs across those and creates all of this into a large namespace that you can share out. This is particularly popular in high performance computing environments. And then the other thing is workflows. So traditionally, your ingest server, your cleaning and tagging servers, and training servers, which are GPU heavy, and inference servers are all different. And the problem is when you work with very, very large data sets, there's a huge amount of time wasted in ingesting data and then copying it over to another server for cleaning and tagging and then copying it again. With this type of technology, we can ingest the data to these drives, and then you simply virtually move the drives with the NVMe over Fabric tools to another machine. And now we can start processing against that data. So if you think about data itself has a lot of gravity and it's hard to move, and sometimes your data is not in the right place at the right time. This gives you the ability to solve a lot of that and move things very quickly from server to server without actually physically copying anything. And so we start to see these kinds of interesting workflows with that kind of technology. So I know that was a little bit of a long-winded answer to the question about NVMe over Fabric, but hopefully that helped answer.
Yeah, definitely appreciated. The other question that I just saw pop up a few minutes ago was, what kind of GPU is used? And is it dedicated or can it be shared?
Oh, that's a great question. So let me go back to my screen because I shouldn't have stopped sharing. I can actually scoot back up and show you the picture of the GPUs that we use. Today, we actually are marketing two different models, and this one is really an NVIDIA A2000. So it's a small card, half height, a half length, PCIe Gen 4x16. And then we have this card here, which is also a small form factor T1000. So those are the two cards that we ship with our software today in a bundle. We do not change these cards. They're off-the-shelf NVIDIA GPUs. One of the nice things about them is they're readily available in the market. So we're not delivering our software on things like a $30,000 H100. It's unnecessary for what we do. We don't need that much performance. We don't need to sell you a $30,000 card to run RAID on. These cards are very inexpensive in the market. And once again, we sell them with our software, which is licensed based upon the number of drives that you want to protect in your system. So we do have support for other GPUs from the NVIDIA family, which we primarily have tested and provided to some OEMs that would like to use a different model than we ship out into the market. And the other question I think was, does this have to be dedicated? And the answer is yes. When we load our driver on one of these, it becomes a RAID controller. It no longer looks like a graphics card. So we take over that card and use it just for RAID processing. We have tested on some of the higher end models that allow you to do multi-instance GPU, and we have demonstrated that we can run in a MIG instance on an A30 or an A100. So in that case, you could use us on the corner of a GPU and still use the rest of that GPU for applications. And it's theoretically possible for us to put our software on other manufacturers like Intel and AMD, but we haven't found a need to do that at this point. So these are the ones that we support today.
All right, I have one final question. Are any of the major server manufacturers going to offer your technology on their servers?
Yes. So today, Supermicro already does, and they have 4 or 5 different platforms that they're now offering. We also have Gigabyte, which some of you may not be aware of. They're a little more focused in Asia, but they're starting to pop up here quite a bit. And we are very, very active with ongoing tests with a major server manufacturer out of Austin that some people would know. And we also have active tests with another server manufacturer up in Raleigh, Durham, that you would probably know. So there's no way to answer 100% whether those guys are going to take it, but we believe that we're going to knock those dominoes down one at a time, because we're now with Supermicro winning some very large deals with them, and the other ones are taking notice because of that. Great questions.
Looks like. Oh, okay, great. Does anyone else have any other?
I do. I have a typical heard something and get in trouble because I'm a salesperson question. When you mention compression, is that a future wish list, or is that on a roadmap?
I wouldn't say it's on a roadmap yet. We know it's possible to do. We do work with companies that already provide that. So the same with encryption. So the traditional drives out there that do encryptions, or we call them SED drives or self-encrypting drives. There are also some drives that have what we call computational storage on them. So if you look at ScaleFlux, for example, you know, they build a drive that actually does encryption and compression on the fly as you write to it. And we actually have tested and support them and partner with them as well. So, you know, the concept of whether we ever offer encryption or compression on our card, it's not really a technical issue to do it. It's, do we want to do it? Do we see a need in the market for it? So that's still under evaluation, but we bring that up to show the flexibility of this platform and being able to deliver new capabilities through software alone. A great question. And my boss, Tom, actually put in the chat that we have certified 10 servers with Supermicro. I'm not sure where I got 4 in my brain, but yeah, we have 10 servers, platforms that are validated with them now.
Are there any other questions? If not, we're going to go ahead and do our spin to win. Kelly, thank you so much. And of course, we encourage everyone to stick around after the spin to win to ask any questions or get any answers, I suppose. So I will, Kelly, I'm going to cut you off.
Do it.